So I want to explain this beautiful article from Percy Leong, Data Recombination for Neural Semantic Parsing. I will explain this data flow as dialogue as data flow in my playlist for dialogue systems, because this is the work of semantic machines in Microsoft. And so, semantic parsing is very important for dialogue systems. It's very important for reading comprehension and many other applications. So these are great scholars, very great scholars. And an example from natural language to program could be, for example, what movies has Tom Cruise been in? You can see it as a program. So we have compositional semantics. We combine predicates. And we have conversational semantic parsing. Another example for semantic parsing. And the data sets like Geo, Addis, and Overnight, which I have explained in the previous lecture, at the end of the previous lecture. So there are some nice articles, so we want to focus on data recombination for neural semantic parsing, Percy Leong and Robin. So a nice article from Amazon is this, but the article I want to explain today is data recombination for neural semantic parsing. So data recombination mechanism is not new. It's like injecting prior knowledge into a model. And from the training data, we induce a high-precision synchronous context-free grammar which captures important conditional independence properties commonly found in semantic parsing. We then train a sequence-to-sequence recurrent neural network model with a novel attention-based copying mechanism. We need copying mechanism because sometimes when we say something in utterance, some of the words could be repeated directly. And this reduces the complexity of decoding that we use beam search, very advanced methods of beam search and so on. And so separates the complexity, and it has many concerns, this copying mechanism that I like. So what is data recombination? As I said, data augmentation techniques focus on modeling invariances, just like transformation, like translating an image or adding noise that's altered inputs but do not change the output. So consider this utterance. What states border Texas? It should be easy to generalize to questions where Texas is replaced with the name of other states. So simply we replace the mention of Texas in the logical form with the name of the new state. Strong conditional independence principle says that the meaning of the rest of the sentence is independent of the name of the state in question. So the idea of data recombination, you got the idea, it's just augmentation. And neural semantic parsing, so there are three types of semantic parsing: recurrent neural network, traditional logical compositionality, and recombination methods. Of course, you can generalize it in different ways. Neural semantic parsing, we construct a generative model by just inducing a synchronous context-free grammar. So the encoder, you could use LSTM to encode that, so it's pretty obvious. And decoder, you can use any attention-based model. But also you can add the copying mechanism. So it's combination. So sometimes you just use attention mechanism, just like normal thing. But sometimes you just use copying, because some of the words in the utterance could just be copied from the utterance to the decoder, therefore reducing the complexity. We want to train with data recombination. So here we do some augmentation to have more data, and then we use the gradient descent and we maximize the likelihood. Everything is standard. So there are many things. So the idea or the contribution of this paper, let's say, is just adding some recombination. Adding some data. For example, we use some techniques. For example, the techniques that we use is abstract entities. You see, we have X and Y. What states border state I? So we generalize it. We say it's a type. It's a kind of type, state ID. So we are abstracting the entities. And therefore we can generate lots of utterances. So we grow as our training data. The other technique is abstracting the whole phrase, like this example, that what states border states. So state is just, we're abstracting the whole phrases. And the concatenation is just, we are concatenating. And here, for example, an example of concatenation, we are concatenating sentence 1, sentence 2, sentence 1, sentence 2. For example, you will see the sentence 1 is what states border Texas. The second sentence is what is the highest, so we concatenate them. The other one is composition of any of these two, any of the three techniques. For example, combine concatenation with abstract entities, or combine abstract whole phrases with concatenation, and so on. And this article is also very interesting. Another good article is this, improving semantic parsing with neural generator re-ranker architecture. This could be useful for those who are interested in reinforcement learning, although they didn't mention that you can use reinforcement learning.